it starts at the origin.
Yes.
And then it goes up by a quantity of direct, like, and then when, say your vector is 3i plus 4j, it would start from 0, and so the coordinate would be 3, 4.
No, that's okay. What you are saying is perfectly right. But the basic thing remains, what is the position vector? How do we represent it? That's what you have said. What is a position vector? How will you explain to a young child? The simple definition you need to spell out that it represents the position of a point with respect to some standard point. Okay. It gives us the location of a point with respect to some standard point. For example, मैं बोलता हूँ आप X शॉप से ये चीज लेकर आओ. अब आप पूछते हो शॉप कितनी दूर है, ठीक है, तो मैं आपको बोलता हूँ 100 मीटर दूरी, ठीक है. अब ये 100 मीटर मैंने कहाँ से नापा?
The shop, the first one.
नहीं, the distance of shop is 100 meter, but from where?
0.
What is that 0 for me?
Your house.
Naturally, it's my location, which I take as reference, and then I tell you the distance of a point. So we always have a reference point, which we normally call origin for representation. And with respect to that origin, if I'm fixing the point on the graph, then I say this line OA or OB or OC, whatever, with respect to origin, spells out the position of that point with respect to origin. So all such vectors are termed as position vectors. So a position vector gives me the position of a point with respect to origin. Okay. So how will you define statement? लिख लो ये वाला.
A position vector gives the location of a point with respect to the origin.
Correct. So that is a position vector. So in my normal graph, I call it x-axis, and this is y-axis. Okay, and this is the point A. I join this OA. This is O origin. Then this particular vector, which I am naming here as A, is the position vector of A. Okay, so I have a vector A, position vector of OA. It is equal to this vector OA. Okay?
Yeah.
So I can write this vector A as A into A cap. Can I? Now, what this A represents here and what this A represents?
A would be
this
mine.
This A is magnitude of this vector A, and this represents the direction, unit vector.
Yeah.
So this length of vector OA represents the magnitude, and this vector in this direction represents a unit vector.
Yeah.
Okay. So how many times this retake gives me the actual magnitude of this vector? 4 times, 5 times, 6 times, or 4.5 times. That spells the magnitude of this vector. Okay. Now suppose I drop a perpendicular from this point to x-axis. This is a perpendicular, so I name it O, say P, and then A. If I use the triangle of vectors, I can very well write vector OP plus vector PA is equal to vector OA. Now what is OP? OP is the component of this vector along x-axis.
Yeah.
And what is PA vector? Is the component of this vector along y-axis.
Yeah.
And both these OP and PA are perpendicular to each other.
Yeah.
Therefore, we call these as rectangular components of vector OA. Here we use two special vectors, I cap as unit vector along
x-axis
and j cap unit vector along y-axis. Okay?
Yeah.
If magnitude of OP is say x and magnitude of PA is y, then I can write this vector A as x times I cap plus y times j cap.
Yeah.
Okay, beta?
Yeah.
Now, in this representation, what this x and y are?
The magnitudes of OP and PA.
Yes. We call it scalar components.
Yeah.
Scalar components. Okay?
Yeah.
And what do we call this and this as a whole? These are vector components. If you take I cap, j cap along, then this becomes vector components. If you take only x and y, which are magnitudes along x-axis and y-axis, then these two are called scalar components. Okay?
Yeah.
And these vector components or scalar components are also called rectangular components. Then x times I cap. X times I cap. What do we call it? Projection of A along x-axis. And y j cap is projection of vector A along y-axis. So these are called projections. This is projection of A on this, and if I drop a perpendicular here, then this is called projection of A on y-axis. ठीक है? ये चीज clear हो रही है? Now, if I have to find the magnitude of A, how can I find magnitude of A? I use again Pythagoras theorem in this right angle triangle. X, Y, these are sides of right angle triangle. So what will become the magnitude of A? This is x square plus y square under the root.
Whole square root, yeah.
Okay, so this becomes magnitude of vector A, which we generally represent by simple r.
Yeah.
Okay, now because it is a vector, it has to have a direction also. Suppose this angle is theta.
Yeah.
So this angle in this diagram is theta. Okay, so angle theta with respect to x-axis. Angle theta with respect to x-axis will represent OA, but magnitude of OA is R. Magnitude of OA is R. Okay, so direction is theta from positive direction of x-axis. Okay, so we also write vector OA as r angle theta. So the same vector, magnitude and direction can also be given like this. And when we write a vector like this is called polar form of vector. इसमें भी दोनों चीजें r भी है थीटा भी, ठीक है। तो अब यहाँ पे हमारे पास ये मैग्नीट्यूड है r और ये एंगल हो गया थीटा, और इसी चीज को हम x टाइम्स i कैप और y टाइम्स j कैप और दोनों का सम उससे भी रिप्रेजेंट करते हैं। So we have two ways to represent the same vector, position vector, ठीक है, in rectangular components form or in polar form. Okay, now let's find what is the relation between these two. Okay, to find the relation between these two, let's look at it once again. In this rectangle triangle, beta, what is x upon r? Ratio x upon r क्या होगा?
X
Base upon hypotenuse?
cos theta.
Cos. Base upon hypotenuse is cos theta. Perpendicular
'cause
upon
it's base,
hypotenuse
yeah.
is sin theta. Okay, बेटा ध्यान रखो इस चीज को. So we have x upon r is equal to cos theta. So this gives me x is equal to r cos theta.
Yeah.
So r and theta, if I use like this, I will get the value of x.
Yeah.
And what is y upon r? Y upon r is sin theta. So y is equal to r sin theta. Okay, using this notation, I can write my vector A as r cos theta I cap plus r sin theta j cap.
Yeah.
So using polar form, I have made it in rectangular form. ठीक है?
Yeah.
और दूसरी तरीके से कैसे लिखेंगे? x square plus y square under the root angle tan inverse y by x. This is r, this is theta. ठीक है? ये इंटर कन्वर्शन अगर करना हो तो इस प्रकार से हम इसको अप्लाई कर लेते हैं। सही है बेटा, चलें आगे।
हाँ.